Okay, Rams, for our homework tonight, we are going to go through these problems. You may be watching this because you got stuck on a few, or maybe you want to check over yours, or maybe you felt like the working class was a little bit tough, and you just want some guidance going through it, and that's okay. All right, so we're going to start with question 1 here. Which expressions are not equivalent? Okay, and I wrote down each one here. All right, so what we're going to do is just simplify this as far as we can and see if it's equivalent to 3x plus 25. Okay, well, I have my 3x's, and that's all the x's I have. So I'm just going to write 3x's. Now, over here, I have a couple of different things. I just have a constant here, just the 5. But I also have a number smushed up against these parentheses with stuff inside of it, which means I need to use the distributive property. So I have plus 5 plus, now 2 times 6 is 12 plus 2 times 4 is 8. Okay, so the 3x looks good. Now 12 plus 8 is 20 plus 5 is 25, and they're all positive, so it's plus 25. That looks good. Okay, the next one here, x plus 5 in parentheses minus 2. Okay, that is the same thing because there's nothing I can simplify in here, and there's nothing smushed up against it to multiply. This is just the same thing as x plus 5 minus 2. So my x is just an x, and then I have positive 5 and negative 2. That's like 5 minus 2, which is a positive 3. So that's x plus 3. That is equivalent. Okay, this next one here. All right, this one I have to use the distributive property because I have to do 2 times x. So 2x plus 2 times 5 is 10, and then plus 6. Now my 2x just stays 2x, but I can combine these. 10 plus 6 is plus 16 here. So this one is equivalent to 2x plus 16. So let's try this one here. Again, it's like the one up there where there's nothing in there to simplify, so it's the same thing as saying x plus 5 minus x. Well, if I have a positive x and a negative x, it's like saying I get an apple and I give it away. I have nothing left because they cancel each other out. So all I'm left with is just a 5. Well, here, it's not equivalent to 2x plus 5 because they're assuming that you're going to forget that negative sign there, and we didn't. So this is the one that's not equivalent. Okay, next. Number 2, Janice exercises every day. She spends 35% of her exercise time swimming. She spends the rest of her exercise time jogging. Which percent bar represents the percent of exercise time that Janice spends swimming? Well, before I could even tell what percent it is, I need to know how many pieces there are here to know what each one would be worth. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they all have the same size pieces. So if they're each in tenths, this means each one is 10%. So 10 and 20 and 30. Right, we could go like this on for a while. But now we just want to know which one is at 35%. Well, these are all marked in the tens, right? So I would have to go to 3 1/2. I would have to go halfway to the 40 on the next square. So it is this one because this is 10, 20, 30, and a half of another one, so 35. Okay? All right, right here, this was from the last unit, solving a one-step inequality. So a lot of people make mistakes with this, and we think of this as like a negative 3 plus x. No, it is negative 3 times x. They're smushed up against each other, and there's not another symbol in there. There's no operation there, so that means multiply. So the opposite of multiplying by negative 3 is to divide by negative 3. Okay, well, negative 3 divided by negative 3 is 1, so it leaves me with just an x over here. But we have a very special rule that says when I divide by a negative, like I did right here, I have to flip that inequality, and so instead of less than, it becomes greater than. So then I go right over here, and what is negative 21 divided by negative 3? That would be a positive 7. So x is greater than 7. Now, what seems really funny when you're saying negative 3x is less than negative 21, but try some numbers. Try a 6, try a 7, try an 8. Just remember your rules about integer operations, okay? All right, this is the distance the Blaylock family traveled, as shown in the table below. Which equation represents the relationship between hours and the distance traveled? Okay, so we're looking at distance in terms of hours. So basically it's saying to get from H, see right here, there's always an operation with my H. So what do I do to this 2 to get to 100? What do I do to this 3 to get to 150? Well, of course I could add 98, but it doesn't work for all of them. I've got to find a rule that works for every single one of these. So to me, it looks like I would say multiply by 50. Multiply by 50. 3 times 50 is 150. 5 times 50 is 250. So if I take hours and multiply by 50, I'm going to get the distance. So which of my equations looks like that? That's A. D equals 50H. Okay, next. Number 5. The table shows the relationship between X, the number of hours that Roberto worked, and the amount of his earnings, Y, for the hours worked. So which equation represents the relationship between the hours that he worked and his earnings for those hours? Okay, so Y is the earnings. So I always want to know, start with X. What do I do to this number to get over there? What do I do to 2 to get to 17? And I could check each of these right here. I could say, well, I could substitute a 2 in there. Is 2 plus 15 going to equal 17? Yes. But if I put 3 in there, is 3 plus 15 going to equal 2550? Would that equal 2550? No, it would be 1850, right? So it's not going to work there. 2 times 8. Oh, my iPad's freezing up here. I'm sorry. All right, so 2 times 8 is not going to be 17. Oh, this is actually a 2-step equation, so it's for sure not going to be one we use because this is multiplication and addition. 8.5x, and you could check that and say, is 2 times 8.5 going to be 15? Yes. Is 3 times 8.5 going to be 25.5? Yes. You can always think about your earnings as multiplication because if you take the amount that you earn per hour, and in this case it was $8.50, and multiply it by the number of hours, that gives you your total. So earnings are always multiplication. All right, number 6. Use the ordered pairs shown in the table below. Which equation represents the data that's in the table? Oh, man, this one's kind of crazy looking, right? I see some fractions in here. But that's okay, because I can look at this. If I wanted to simplify it farther, I could even say 10 and 15. Now, you could also simplify down as far as you wanted to go and say, well, if 10 and 15, what if I wanted to go with 1? If x is 1, what is y going to be? Well, I could divide by 10 and divide by 10. Y would be 1.5. So basically this is saying that no matter what x is, y is going to be 1.5 times as much. Okay, but the question right here, on the first one here, y, it's saying that y times 1/3 is x, but it's not. It's actually 2/3. So it's a little bit different there. But it's now is where we get tricky. Because is it x equals 1.5y or y equals 1.5x? Yeah, that is tricky, right? But think about which one. What are we doing to this number here? We're multiplying 1.5 times this top number to get the bottom one. But when we write our equations, and we'll be talking about this in class, we write it in the form of y equals kx, or y equals, is it a x plus c, I think. But it's always in just y equals. So if it has x equals, you don't typically want that unless it's asking for it worded. It'll say in terms of this. Okay, it'll give you a different little phrasing, and we'll practice those in class. All right, the table below shows the relationship between x and y again. Which equation best represents the relationship between x and y? Again, all of your answer choices have a y equals. So it's saying what happens to my x to get to y? What am I doing right here? Okay, so a couple of things. That one looks a little bit tricky here, right? This actually is a two-step equation here, but that's okay. We can substitute some numbers, okay? We can look at it and say, well, 5 times 4 is 20, but 6 times 4 is not 25. Okay, let's try 4x plus 1. So 5 times 4 is 20 plus 1. Nope. Okay, 5x. 5 times 5 is not 20. Okay, so let's try 5x minus 5. So put 5 in there for x. So 5 times 5 is 25 minus 5. Yep, that's 20. Let's try here. 5 times 6 is 30 minus 5 is 25. 5 times 7 is 35 minus 5. So as long as you can then substitute the numbers for x in for each one, it works. Okay, last question here. Use the relationship shown in this graph. Which equation shows the distance y in terms of hours x? See, it tells you in like how do you get to y based on doing something to x here. So x is always the time. So if I say x and y, let's just plot a coordinate grid for a second. Have 1 and that's up halfway, so it's at 50, right? 2, I go over 2, I go up 100. That's all I need. So how do I get from x to y? I am multiplying by 50 each time. 1 times 50 is 50. 2 times 50 is 100. This one has 5 times 50 is 250. Okay, so y equals 50 times x. All right, make for sure that you have the work for all of these, and we'll check them in class.